The horizon darkens, not with storm clouds, but with wings. 3 billion passenger pigeons surge across the Wisconsin sky like a living river, their bodies packed so densely they block the sun. Below, the forest floor disappears under falling feathers and droppings. The thunderous roar of displaced air drowns out every other sound, a biological storm that shakes the earth. This is 1871. The flock stretches from horizon to horizon, flowing like liquid mercury across the canopy. Individual trees bend and snap under the weight of 100,000 birds. When they finally pass, they leave behind a landscape transformed. Clearings torn open, soil chemically burned by nitrogen-rich waste, the very architecture of the forest rewritten. 50 years later, the skies are silent. How did the most abundant bird on Earth, a species that constituted nearly half of all bird life in North America, vanish faster than it took humans to build a single railroad? The answer lies in a fatal evolutionary miscalculation. The passenger pigeon had become too perfect for its own survival. Every inch of the passenger pigeon's anatomy was engineered for one purpose: speed at scale. Their wings stretched long and pointed like a fighter jet's, designed not for agility, but for marathon endurance. These birds could cruise at 60 miles per hour for hours, covering hundreds of miles in a single day. Their oversized breast muscles powered deep, rapid wing beats that never seemed to tire. But it was their tail that revealed their true nature. Long and graduated like a ship's rudder, it provided the split-second control needed when a million birds suddenly changed direction. In the chaos of the megaflock, collision meant death. Every bird needed perfect spatial awareness, perfect timing, perfect synchronization with its neighbors. They were not individuals, they were cells in a superorganism. The crimson eye of a male passenger pigeon could spot a falling acorn from 1,000 feet. His iridescent neck feathers caught and reflected light like a signal mirror, flashing messages through the dense canopy. When he called, his voice joined a chorus so loud that observers described it as an army of horses laden with sleigh bells. The females, cloaked in cryptic browns and grays, became invisible against bark and shadow. Essential camouflage for birds that nested in the open, their flimsy platforms exposed to every hawk and owl in the forest. This was no ordinary bird. This was evolution's answer to a continental-scale logistical problem: how to find scattered, unpredictable food across millions of square miles of forest. The oak trees held the key. Every few years, they would synchronize their reproduction, carpeting the forest floor with billions of acorns. Then, for reasons still mysterious to scientists, they would go silent, producing almost nothing for seasons at a time. The passenger pigeons had evolved to chase these boom and bust cycles, becoming nomadic wanderers enslaved to the tree's irregular rhythms. Recent genetic analysis reveals something extraordinary about these wanderers. Despite numbering in the billions, passenger pigeons possessed remarkably low genetic diversity, the kind typically seen in critically endangered species. In massive populations, natural selection becomes ruthlessly efficient. Beneficial mutations sweep through the gene pool like wildfire, dragging along entire chromosomes in their wake. Over millennia, this process had streamlined the passenger pigeon genome into something unprecedented, a genetically optimized superspecies honed to perfection for life in the swarm. But perfection has a price. They had become so specialized for abundance that they could no longer survive scarcity. The telegraph changed everything. Before 1840, a nesting in Michigan was local news, known only to nearby hunters and farmers. By 1870, station masters could instantly alert professional hunting syndicates in New York and Chicago to the exact coordinates of any gathering. The railroad followed, carrying hundreds of hunters and their equipment to remote nesting sites in a matter of hours. Ice-packed barrels solved the final piece of the puzzle. preserving meat for urban markets hundreds of miles away. 3 inventions had created a continent-spanning trap: telegraph, railroad, and industrial refrigeration. The economics were brutal in their simplicity. Dead pigeons sold for pennies per dozen, but the flocks were so massive that volume compensated for razor-thin margins. A single hunter could net hundreds of birds in minutes using techniques that exploited the species' most fundamental behavior, their compulsive need to join any gathering. The stool pigeon was no metaphor. Hunters would capture a live bird and sew its eyelids shut with thread, leaving it docile but still able to flutter. Tied to a movable perch, the bird would struggle when the hunter pulled a string. Passing flocks, seeing what appeared to be another pigeon landing, would descend en masse to investigate. They walked directly into nets that could hold 1,000 birds at once. But it was the disruption of the nesting colonies that sealed their fate. The cities, as observers called them, were biological marvels that sometimes covered hundreds of square miles with nests packed so densely that trees collapsed under their weight. In 1878, professional hunters descended on a nesting near Petoskey, Michigan. Over 7 weeks, they shipped out more than 1 million adult birds by rail. Countless more squabs were left to starve when panicked adults abandoned the colony. The hunters had discovered the species' Achilles heel. Passenger pigeons were obligate socialites. They required the visual and auditory stimulation of massive flocks to trigger the hormonal cascades necessary for reproduction. Below a critical threshold, perhaps a few million birds, the psychological machinery of breeding simply shut down. Scientists call this the Allais effect. For most species, survival becomes easier as population density decreases. Less competition, more resources per individual. But for passenger pigeons, the equation was reversed. As their numbers fell, their fitness collapsed exponentially. A flock of 5,000 birds might be biologically capable of reproduction, but psychologically incapable of achieving it. The final collapse unfolded with mathematical precision. By 1880, the great cities had vanished. Scattered flocks still formed, but they were quickly located by telegraph and eliminated before eggs could hatch. In 1896, the last significant gathering of perhaps 200,000 birds assembled near Bowling Green, Ohio. Word spread through the telegraph network. Hunters converged from across the region. Within days, 200,000 adults lay dead, and 100,000 helpless squabs were left to die of starvation and exposure. The survivors scattered to the winds, never to gather again. Martha spent her final years in the Cincinnati Zoo, a relic of a vanished world. She had outlived her entire species, watching from behind bars as the forests fell silent. On September 1st, 1914, she died quietly in her cage. For the first time in human history, we had watched a species go extinct with the full knowledge that we were the cause. Today, the eastern forests seem peaceful, cathedral-like in their stillness. But this silence is not natural. It is the echo of an absence. White-footed mice now feast uncontested on the acorn masts that once fed billions of pigeons. Their populations have exploded, carrying with them the bacteria that causes Lyme disease. Even in extinction, the passenger pigeon shapes our world. Scientists are now attempting something unprecedented: resurrection. Using genetic material extracted from museum specimens, they hope to edit the genome of the band-tailed pigeon, the passenger pigeon's closest living relative, to recreate their extinct cousin. But even if they succeed in building the hardware, the software is lost forever. The cultural knowledge of migration routes and nesting sites died with the last wild flocks. The passenger pigeon story is more than a tale of industrial greed and biological miscalculation. It is a warning written in the language of evolution itself. that abundance is not insurance against extinction. For a species that had evolved to succeed only in overwhelming numbers, the path from billions to zero was not a gradual decline, but a mathematical cliff edge. In the space of 50 years, humanity learned to weaponize the very social bonds that had made the passenger pigeon the most successful bird on Earth. Their trust became betrayal, their unity became vulnerability, their perfection became their tomb. The most abundant animal on the planet discovered too late that in a world connected by wires and rails, there was nowhere left to hide.